Hi, so today we are going to do ISI problem 2 of year 2019. So the question has four subparts A, B, C, D. The distribution you can see here 7, 5, 5, 8. Now what's the question is? So question says about that there are two random variables x1 and x2, both are uniformly drawn from 0 to 1. Now this function g of p is given like this. So a part asks you that you need to find g of p, and the other part b, c, d are very easy if you do first part. So now what the solution is? So first of all, we need to plot the uniform distribution range of x1 and x2. So here you can see x1 ranges from 0 to 1 and x2 also ranges from 0 to 1. So this is the domain part of our probability density function. So now this is very simple exercise to plot max of x1 comma x2 is equal to p. We can get a simple inverted L shape indifference curve that we have done in our microeconomics exercises. So you can see that max of x1 comma x2 is equal to p has an inward shape level curve, that is p to p. But question asks that max of x1 comma x2 is less than equal to p, which means that we need to pick all the x1 and x2 such that our maximum of those x1 and x2 must be less than of p. So those x1 and x2 lies in this square region. So the area tells you about the probability. So the probability is nothing but p into p, that is p square. So we can see that probability of max x1 comma x2 is less than equal to p is equal to p square, which is the shaded area. Now a part asks about that g of p is equal to p into this function. Now we calculated this as a p square. So if we substitute it in this equation, then we get p into p square, which is equivalent to p cube. Now the next question asked you to plot the g of p, which is equal to p of p cube, which is very simple. We have done this in maths exercise like y is equal to x cube graph. So it is drawn in this domain, that is 0 to 1, in this shape, which has a maximum value is 1 at 1 and least value is 0 at 0. So next part ask about the curvature of this function. Now we can do this part by two alternative approach. First approach is that we can simply apply the definition. So if we apply the definition of a convexity, then we can pick any arbitrary p1 and p2 which belongs to this domain 0 to 1. Then the convexity definition holds. So we can see that p1 and p2 convex combination. If we put this convex combination in this function, then we can get g of lambda p1 plus 1 minus lambda p2, and we can clearly see that this convex combination always lies below this red line, and the red line is the convex combination of the g of p1 and g of p2, where lambda belongs to 0, 1 and for all p1 and p2. So this tells you that this function is convex. And alternative approach is the calculus approach, which we have done in undergrad. That is we can see our function is g of p is equal to p cube. So first differentiate 3p square. Second order derivative is 6p. Now 6p is strictly positive for all the p values from 0 to 1, so hence convex. Now for second part, that is D part, what we can see is that max of g of p is equal to p cube. What we need to do in this question, we have to find the max. So what we know that that g is a strictly increasing function, so maxima will occur at the end point. So the end point is 1, so we can clearly see that if p is equal to 1, then function reaches its highest point, that is 1. So g of 1 is 1. Thank you.